Hi, everyone. I'm Perry Webster. I'm a specialist solution architect for SAP applications on AWS.
Hello, everybody. My name is Ravi Kashyap, and I'm an SAP Solution Architect here at AWS as well. And today we are talking about Q Developer and SAP DevOps and AIOps activities we can do with Q Developer. Let's get started. What comes to your mind when you think about Q Developer? I suppose first thing that comes to my mind is about code. And that's the myth we are trying to debunk today. Q Developer and Q Developer CLI are not only for coding function, but you can use it as a DevOps assistance as well. And that's what we are going to show this in the use cases. In our setup, we are using Q Developer add-on to VS Code and Q Developer CLI configured with MCP servers. Let's get started.
Great. All right. So now we'll go into the actual demonstration. All right. Hi, everyone. Yeah. So today we're going to talk about how we can do infrastructure sizing, mapping, and deployment with Amazon Q Developer inside the Visual Studio Code IDE. We'll start with this first example. We're going to start with a simple file within SAP that has the server specifications of your on-prem environment. Let's take a look at that file. You can see that it has the SAP product, the current size, what environment it is, the number of CPUs, the memory, the storage, etc. Fairly typical information you might get from any system on-prem. This file doesn't have to be in any particular order. We're using generative AI to analyze the file, the structure, and make appropriate decisions. Let's now talk to Q Developer. Q Developer is going to help us map this to an infrastructure on SAP. Let's give it a sample prompt to do that. So in this prompt, I'm telling it I'm looking to map these systems to AWS. These are listed in a particular file. I've given it that file name. I've instructed it explicitly to look for SAP certified instances on AWS because it's very important that they're used in this type of diagram. I've also told it to use the latest generation and to verify that all of its output is correct using a Python script. We have to be very careful when mapping SAP systems that the CPU and RAM is appropriate for the environment. Let's go ahead and let this run. All right, we can see that Q Developer has started to create a Python script to map the environment to AWS. It wants me to run this shell command to give it a shot. I'll go ahead and do that. Looks like it can't find Python, so it's going to run Python 3. So great. Yeah, so you can now see that it's created a mapping using that script of all of the instances in a sample on-prem inventory. We can run this script as well to generate the summary report. All right, we can see that Q Developer has successfully mapped all of the on-prem environment to AWS. It found 31 separate servers, it used all the latest AWS instance types, and it has validated that they are SAP certified. It's provided them in both JSON and CSV format and summarized the results and validated that the overall CPU and memory is appropriate for the workload. Additionally, it provided some helpful information about a couple of larger instances that need additional capacity. So with that, you can see that within just a few minutes, we've been able to map what was potentially your on-prem environment of servers for your SAP estate into an AWS environment. So now that we've mapped the system to AWS, we want to actually try deploying a sample of the environment. In this case, we're going to start with the initial SAP ECC systems and generate Terraform that would deploy this in a secure, highly available manner. And we're going to ask Q Developer to do that for us. So let's use the following prompt to do that. We're going to explicitly tell Q Developer that we want to map just the SAP system, so we're not going to look at all the others at this point. We're going to migrate to Red Hat Enterprise Linux instead of Windows on AWS. We're going to tell it to generate all of the Terraform code using the US East 2 or Virginia region within AWS. And it's going to do this by querying a model context protocol Terraform server that AWS provides. It's going to include everything that's needed, security groups, routing tables, encryption keys, etc., and follow the best practices for security and resiliency at SAP. I've also told it to move this from a non-HA environment on-prem to leveraging the best of high availability on AWS. So let's go ahead and let this run. All right, you can see that it is looking to create the Terraform scripts. It's going to create a subdirectory for all of those pieces of it's going to create a subdirectory for all of the Terraform scripts to be deployed to. You can see now that it's creating user data scripts, so the Terraform can automatically perform actions within the EC2 environments that prepare it for an SAP deployment. All right, and it's wrapped it all together with a deployment script that it wants to make executable. It's also created a validation script to make sure the Terraform code is working properly. All right, you can see that after just a few minutes, we've created a Terraform script to deploy your entire SAP estate. It's done this in a format using modular code for storage, security, compute. It's done it for the systems requested, and it's created it with high availability for the production environment. In general, you can see that it's followed best practices for both AWS and SAP and created a reusable directory structure if you want to practice deploying this in other environments. Additionally, it provides deployment instructions to wrap around the basic Terraform scripts, and has even gone the extra mile here and provided a cost estimate for this deployment. So kudos to QDeveloper for doing that. All right, so now that we have the Terraform script and this entire environment could be deployed, let's see what's actually been created. So I'm going to minimize the chat window and look at the actual file system structure. So you can see that we already had the mapping to JSON and CSV files, but it's also created an entire Terraform directory structure with the scripts needed and literally hundreds of lines of code that have been generated to deploy this environment. It's done this in a modular fashion so that you can adjust the environment variables that you need for your particular deployment, should it differ, or if you just need to run differences between iterations of this program. So with that, there's only one other item to look at, which is we want to actually create a diagram of the environment. Okay, we're back. Yeah, I hope you enjoyed the Terraform session. Now we want to actually see what was deployed. The easiest way to view that is to look at a diagram. Let's just simply ask QDeveloper to do that. Generate a diagram to show what was deployed using draw.io XML format so I can edit it later. All right, looks like QDeveloper has completed the draw.io diagram. You can see it's a summary of the overall deployment showing the availability zones, the subnets, the network configuration, and the EC2 instances with the various amounts of storage. Let's now take a look at what that actually looks like. You can see that the diagram summary is in the root folder here. So if I do a ls-l, we can see the draw.io file. Now let's open that up using draw.io. All right, welcome back. You can see right now that the diagram that was created in draw.io for the architecture that was created in QDeveloper. You can see that it's correctly placed the database in its own subnet. It has a primary and standby, as well as application servers to support that. All right, so now you've seen the Terraform diagram. And with that, I'll hand it over to Ravi, who's going to walk you through some cost optimization and SAP querying scenarios.